Hi guys, this is Ayush and I'll be talking about RStudio. RStudio provides a user-friendly environment to write R scripts and execute them. One major advantage of RStudio is that it's an open source tool. That is, it is free for individual use. First, I'll go through the installation process and then we'll proceed. Before installing RStudio, you need to install R. So the link provided here will take us to the location where you can download R. Since I already opened it, it's right here. Click on the download R 3.3.3 for Windows button if you're using Windows as a platform. Click on download R 3.3.3 for Windows if you're using Windows as an operating system. Click on save file. After downloading R, we need to download RStudio. The link provided here would take you to the page where you can download RStudio. That's the link. If you're using Windows operating system, you can download using the first link. Other operating system users can also download their version of RStudio. So I'll be downloading RStudio for Windows as I am using Windows. Save file. Once the download is complete, we'll first install R. This app. Choose the preferred language. Click on next. Do read the public license if you want to. Next. Choose the directory where you want to install. Since I already had the file, I'll use the same location folder. Select all the files. I would advise you to accept the default settings. Next. The installation will take less than a minute or maybe a minute or two to complete. While the installation goes on, I'd like to tell you that R is the most widely used scripting language for data analysis. We'll talk about data analysis at the end of the video. The installation is complete. Now we'll try to install RStudio. Allow this app as well. Next, choose the default directory. Install RStudio. This installation will also take a minute or two. Now we have installed R as well as RStudio. Let's open it now. For opening RStudio, either you can type RStudio in the search bar in your Windows, or you can open it through the shortcut created on your desktop. This is how RStudio looks like. The top left one is the one where you write the scripts. The bottom left one is where you can see the outputs. Bottom right is where you can see files, plots, packages, help, and viewer. Help is a very important tab here because RStudio provides you with definition of the parameters and the function in this help tab. In packages, you can see what packages are available and install more packages. Plots is where you can see the plots when you use plot functions. Files is the files available in your working directory. The environment and history tab takes care and gives you what the variables store, and you can also edit the variables here. Now let's get started with RStudio. To create a new R script, you can click on this button or go to File, New File, and then R script. You can also open an existing file or see the recent files here. Other options available is to close and to save. Let's now create a new file. I generally prefer saving the file initially itself so that I can name the file. Let's name it new file 1.r. Save. So we have that R script new file 1.r here. Before we start writing the R script, one thing is very important, that is setting up the working directory. The method used to do so is setwd. Like you can see, the parameters passed is the location of the working directory. You need to note just one thing, that instead of backslashes, there are forward slashes present in the name. Once you do so, run the command. So the working directory is set to RStudio dummy, which is present in desktop. You can also get the working directory by using the function getwd. So my working directory is C users HP PC desktop RStudio demo. It is good to save files as frequently as possible. Shortcut command to do so is Ctrl S, as in any other programming language or tool. Options available here are to edit, code, view, plots, session. So in session you can also set the working directory without using the command and directly selecting the source path. Debug is used to debug your code. There are certain tools provided inside RStudio. You can install packages from this section, or you can install packages here, or you can use the command install.packages to install packages. Now we'll continue and know about the basic data types present in R. Few of the basic data types available in R is logical, numeric, integer, and character. Logical data types stores only true and false. If I run this particular line, it says TOF is equal to true. When we see the value of TOF, we can see it's true. We can use class function to see what's the type or the class of the variable. Like you can see here, class of TOF is logical. When I gave TOF in quotes, it was not mentioning the variable TOF but a string TOF. All the strings, single character or double character, are represented by character data type in R. Let's go to the next data type, which is numeric. You can check if a variable is an integer, a numeric, a character, or a logical variable by using function is with the data type and the parameter as the variable you want to check for. So is dot numeric as a should give me true, as a is a numeric value. Numeric value is a floating point value, that is, it takes decimal values. Integer, on the other hand, takes only integer values, that is natural numbers 1, 2, 3, 4, and so on. You can see the class of this variable b by saying class of b. Integer. Another thing about integer is it's a subclass of numeric. So every integer value is also a numeric value. Already mentioned above, if you give a variable in quotes, it would give a character value. Class of C would be character. Now, since you know about the basic data types, I would go on to describe some basic data structures available in R. Vector or matrix are synonymous to 1D and 2D arrays in other programming languages. You can create a vector by using function C and putting the values separated by commas. So vector V would have values 1, 2, 3, and vector VC will have values ABC. If we check the class of V, we would get numeric, as I pass integer values and all integer values are numeric as well. If we check class of VC, all values are characters. Vector only takes similar data types. So if we take another variable v1 and put 1 as well as a in the vector, both the variables will be typecasted to character. So if we see the class of variable v1 or vector v1, it would give us character. So vectors only take one data type at a time. It can't take different data types. For that we need to use list. We'll be talking about list later on in the video. Suppose if we need to give names to the columns, we can use the name function. So name of every value in V is same as the values enter in VC. That is, now if we execute the command, now if we check vector V, we'll have column 1 named as A, column 2 named as B, and column 3 named as C with values 1, 2, and 3 respectively. Another data structure available is matrix. Matrix can be created using the function matrix. If we give the values 1:6, n row is equal to 2, it will create a matrix with 2 rows. Since we gave the values 1 to 6, it will automatically generate 3 columns, since number of rows is equal to 2 is predefined. We can see the values are filled column wise, that is 1, 2, 3, 4, and then 5, 6. If you want to change the order of filling of numbers, you can provide fill the numbers by row is equal to true. You can notice the change that the numbers are filled row wise, that is 1 2 3 then 4 5 6. Two functions rbind and cbind are very important functions available in R. Rbind will add a row to the existing matrix and cbind will bind or add a column to it. So if we write m is equal to row bind of m comma 7 8 9 would add a row to the already existing matrix n. Since I added a vector 7 8 9, that is 1D array, to the matrix n, what if we want to add a column to the same matrix? This command would add another column to the matrix. So another column 1 2 3 is added to the matrix. Since we have learned about vectors in matrix, how to access it. In general, in other programming language, the indexing starts from 0. But as you can see, in R, the indexing starts from 1. We had a vector called b with values 1, 2, 3. We can access the first value by giving the index 1. The first column has name A, since we provided name and value 1. Similarly, in matrix, we can give the two indexes separated by comma. So if you want the first value, you have to give 1, 1. Suppose we want the value in the second row and third column. The indexing would be 2, 3. The value 6. Suppose we have to select the whole row from a column. If we type m1, comma, and leave the second part empty, it would select the first row. As you can see, the first row and the vector which we presented here is same 1 2 3 1. Similarly, if you want the column, you can leave the first value empty and give the second value. So the second column will be present here. Output of these operations is a vector. As you can remember, earlier in this video, we named first column as A, second as B, and third as C and vector V. Apart from accessing vector by the indices 1, 2, or 3, we can also access the values by the names given to it. So the name B will give the second value. Another thing which is important when we are working with vectors or matrices or data frames or lists is that we need to take some particular values out of them and store it in another vector or matrix. To do so, we can use multiple techniques. Like if you want a new vector v1 which have the first two columns of v, we can give it as 1 and 2. So v1 will have the first two columns only. Similarly, if we don't want first column and we want only the second and third column, what we can do is we can give minus of first column. That is That is, second and third column will be present and first column won't be present. Now we'll talk about another important data structure in R, which is list. List is similar to vector but can take different data types as well. So if we make a list L using the function list with values 1 and a, the list will have two values 1 and a. As in vector, what would have happened was both the values would have been typecasted to a character. In this particular case, if we see the class of variable L or the list L, we would get list. So if we see the class of L of 1, 1, it would get numerical value because 1 is numerical. Similarly, class of L of 2 would give character value. So we can see that in a particular list we can have different data types. That's one advantage of list over vectors. Another important data structure which we can use in RStudio is data frame. Data frame is somewhat between list and matrices. So matrices have all the values as same data type and list can have all values as different ones. In data frame, each column is a vector. That is, each column should have same data type, but different columns can be different vectors. So considering we have two vectors, v1 as 1, 2, 4 and v2 as A, C and D. We want to create a data frame DF. With these two vectors. We would get a data frame with two columns v1 and v2 and three rows 1, 2 and 3. If we want to access the second column, we could use indexing as 2 and that will give us second column. Similarly, first column in indexing 1 will work. That's what data frame is. We'll be using data frame a lot as it helps us in data analysis methods. Now that we know about the data types, we'll know some arithmetic operations performed on them. So if there's a variable a with value 5 and another variable b with value 6, a plus b would give the sum of them. A minus b will give the difference. A backslash b will give the quotient and a star b will give the product. These operations are same as in any language you have worked on. For exponents, we use 2 stars. So the value is 5 power 6, that is 15625. Arithmetic operations can be applied to vectors and matrices as well. So if we have a vector v1 as 1, 2, 3 and v2 as 2, 3, 4. Sum v1 plus v2 will add each column individually and store it. That is first column of each vector is 1 and 2 will be added, second column will be added together, third column will be added together, and that's what the output says. Similarly, all other operations can be performed. So 3 into 4 is 12, 2 into 3 is 6, 1 into 2 is 2. Now let's talk about conditional statements. Conditional statements, as in other programming languages, are present in R as well. Considering an example where you want to increment a variable a to 6 only if a condition is satisfied. So if b is less than 6, then only increment a to 6. So we can see that a didn't increment because b is not less than 6. What if we see if b top is equal to 6? What will happen? A increments to 6. So if it takes a condition and if it's true, it executes the following statements. Similarly, there is if and else statements. Since the condition is false, the execution goes to the else part. That means a will become 7. That's how if and else works. There are many more conditional statements available in RStudio. That is any and all. Since we have a vector v1 as 1, 2, 3 and we have variable a which stores value 7, if we use any of v1 is greater than a, this would mean that any of the value in vector v1 is greater than a or not. So all the values in v1 is less than, so the output is false. What if we change one of the values to 8? The output of any of v1 greater than a becomes true because we have one value which is 8 which is greater than 7. All takes all the values of vector and compares it to a. So not all the values is greater than a. What if we make a as 9 and see if all values of v1 is less than a, the output should be true because 1, 2 and 8 all are less than 9. So these were few conditional statements available in R. Let's talk about for construct now. For is used to execute same chunk of code many times depending on some condition. So in the case where you want to add sum of a vector v1 for I in 1 to 3, where I defines the index, sum is equal to sum plus v1 of I. Now sum will store the sum of the elements of E1. Till now you would have got a brief idea about how R and RStudio works. As we know, R is famous as a statistical programming language. We'll apply this knowledge to build a small linear regression model. Linear regression is an approach for modeling the relationship between scalar dependent variable y and one or more explanatory variables or independent variables denoted by x. In case there's one explanatory variable, it's called simple linear regression. I have a predefined data set of diseases caused due to exposure to harmful chemicals. So ET represents the exposure time, N represents the normal number of people with that percentage of exposure, and D represents the diseased ones. We build a data frame with these three vectors. So DF would contain a data frame with exposure time, the number of effective patients, and the number of normal patients. Risk is calculated as the diseased by sum of normal and diseased people. So we have the risk vector here. We will analyze this data set by plotting a graph and building a model over this. We plot a graph with risk against exposure time. We can see it's almost a linear graph. We'll try to fit a linear model over this. Model is a variable name in which linear model is fit. LM function is used to create linear model. An AB line fits a linear curve over the model. So we can see a straight line is plotted over the previous plot. What if we want to create a linear model with parameters as the diseased and the exposure time and not the risk and exposure time? The plot is somewhat different because there's no proper direct relation between diseased and exposure time. But there was a proper linear model fit when we plotted the graph with risk and exposure time. Now let's see and analyze a data set called crime tab, which is available in RStudio. Before working on a data set, you may need to install packages called mass. Since I already have that package, I need not install it. But to install a package, the command which is required is install.packages and the package name. So the package name is mass. And to use those packages, the function library is used. Library and the package name. So I've been using mass, and mass has a data set called crime tab. Crime tab dataset is a dataset of student criminal records, where the row names are the distance between middle finger and the thumb, and the column names are the height. The total of 42 rows and 22 columns. You want to see the summary of the data set. Summary will give the total size, that is 300 number of people are present there, the number of factors, the chi-square test, and the p-value. Since there are many zero values, the p-value is NA. We want to see the attributes, that is the names of the columns and the rows. We can use the function attributes. So these are the values, and then that is the row names, and these are the column names. Dimension name 2 is column and dimension name 1 is the row. Based on these 4 attributes, the flower is classified into 3 species, namely Setosa, versicolor, and virginica. If we see the summary of this dataset, we can see that for each attribute, it gives the minimum, first quadrant, median, mean, and third quadrant max value. It becomes easier for us to analyze if we have such functions as summary, which is not available in other platforms as in RStudio. Head function will give us the top 5 or top 6 of the ones in the dataset. With help of summary, attributes, head, and other such functions, we can easily analyze data. That's why RStudio is most widely used data analysis tool. RStudio also provides many packages which helps us calculate statistical values or models, linear models, and any other such statistical models very easy. Thank you for watching this video. I hope you like it. Happy Holi and all the best.